So if we're just trying to produce a transportable gas stream, obviously we're going to do the minimal amount of processing that we can. We just want to be able to do what we can in the field to get it through the pipeline. So the biggest things we have are water, acid gases, and condensate. Are you going to dehydrate it to get it to the LET is the lowest expected temperature in the pipeline. So do we want to dehydrate it to get it below the water dew point? Do we need to remove those acid gases? And part of that might be how much H2S and CO2 do we have? If it's fairly minimal and we might not worry about it, we might use some corrosion inhibitors, pipe internal coatings on your pipes, or use a corrosion resistant steel. There's things that you can do to not have to do this at this point. And if you don't have a long way to send this, transport this gas stream, you might take one of these other things into account. And condensates, again, if your lowest expected temperature of the pipeline is lower than your hydrocarbon dew point, of course you're going to get some condensates coming out or dropping out in the pipeline. So, boy, there are three, hopefully if I blow this up a little, they're gonna show up a little better. Oh, they are terrible. So if condensation is likely, so if you're just trying to produce a transportable gas stream, you can do one of three things. Either don't do anything, don't recover those liquids, and just know that you're going to have two-phase flow in the pipeline. Let me see if I can show you this phase diagram for that. I think you can see that one enough. So that's with nothing. You basically are saying you are in the gas phase, and as your pressure and temperature drop in the pipeline, you'll come into the two-phase region of that pressure temperature diagram or that phase envelope. So you know you're going to have some fluids condense out in the pipeline. You're just dealing with it. Number two is remove the condensate and produce a hydrocarbon dew point with that's less than the lowest expected temperature. And that looks like this phase diagram. Basically, you're taking that phase diagram from out here and shrinking it basically to this, so that when you have that flow in the pipeline and that pressure and temperature drop in the pipeline, you're still in the gas region out here. This is where that McCain book might come in handy. And I say that because I teach the pet fluids class. I just think it's a good book. So you can see you'll still, since you moved the dew point curve, you're still in the gas phase. And then your third one is to compress to a dense phase gas, so the pressure is greater than the Krikonen bar. So dense phase gas, sometimes they'll just call it a supercritical gas. So you're basically taking it from here, super compressing it way up to a really high pressure, and then cool it a little bit. So you get to this point, so even when that pressure and temperature drop in the pipeline, you're still in that dense phase. So remember, if you think about supercritical, it's not exactly supercritical because this is a mixture, but it's in an area at a high enough pressure that it acts both like a liquid and gas. It flows nice and easy, the viscosity of a gas, but it kind of, it has a higher density, a density like a liquid, and it flows like a gas. So it's got some great properties. It's a fluid in the pipeline. It's not really a liquid or a gas. I'm not sure if any of you have dealt with that before, but oops. Let's see if I can get rid of that. So hopefully that makes some sense. So that's kind of your choices for if you're just trying to, if you're trying to produce the condensates or maximize the condensate, sorry, not maximize. If you're just trying to remove the condensates here, here, I keep turning my pen off. Two-phase flow in the pipeline, removing the condensates ahead of time, producing a dense phase gas to just make that transportable gas stream. Okay?